Problem A4. A nonlinear circuit element can be made out of a parallel plate capacitor and the small balls, each of mass m, that can move between the plates. The balls collide inelastically with the plates, dissipate all kinetic energy as thermal energy, and immediately release the charge they are carrying to the plate. Almost instantaneously, the balls then pick up a small charge of magnitude q from the plate. The balls are then repelled directly toward the other plate under electrostatic force only. Another collision happens, kinetic energy is dissipated, the balls give up the charge, collect a new charge, and the cycle repeats. There are n0 balls per unit surface area of the plate. The capacitor has a capacitance C. The separation d between plates is much larger than radius r of the balls. So we have d much larger than radius of balls. A battery is connected to the plates in order to maintain a constant potential difference V. Neglect edge effects and assume that magnetic forces and gravitational forces may be ignored. So we have 5 questions. First I can read all of them, and after that we can discuss them. Question A. Determine the time it takes for one ball to travel between the plates in terms of any of all of the following variables: m, q, d, v. So that's the first question. Question B. Calculate the kinetic energy dissipated as a thermal energy when one ball collides inelastically with the plate surface in terms of any of the following variables. Same one. Question C. Derive an expression for the current between the plates in terms of the permittivity of the space epsilon 0 and any of the following variables: m, q, and 0, c, and v. Question D. Derive an expression for the effective resistance of the device in terms of epsilon 0 and any of other following variables: mass q and 0, c, and v. The same as in previous. And question E. Calculate the rate at which the kinetic energy of the balls is converted into thermal energy in terms of epsilon 0 and any other, like mass, q, and 0, c, and v. So we have 5 questions. So let's do these questions one by one. Question A. Determine the time it takes for one ball to travel between the plates in terms of any of the following parameters. So first of all, if we have charge q with mass m, which is in electric field. Electric field could be counted from this expression, V over D. So the force on charged ball then will be F equal QE, or that's equal QV over D. So we can find what is acceleration from this formula. D equal, we have acceleration A equal force over mass, which is QV over md. And after that find what is time by using this formula. Distance equal 1/2 a t square, and time equal 2d over a square root, so which is equal root from 2d over qv multiplied by md. So that will be just d cube here, d square here. Okay, so finally we have root 2d square m over qv. Question B. Calculate the kinetic energy dissipated as thermal energy when one ball collides inelastically with the plate surface in terms of any of following variables. That's kind of tricky question because we already counted what is acceleration, we know what is the distance, and probably we will go to like a regular kinematic. But this is simple question because we have capacitor with a potential difference V and distance D. So we can count what is total energy which is taken by these balls. Total energy equal just charge multiplied by potential difference. That's the solution. Next question is C. Derive an expression for the current between the plates in terms of the permittivity epsilon 0 and any of following variables m, q, and 0, c, v. So to find what is current, we just use this expression that current equal delta q over delta t. So we already know that we have number of balls for unit area. It's n0. So total charge will be q equal n0 multiplied by area and multiplied by so this is dq multiplied by q. So, and the time we already counted. What was the time? So time was just a root from 2md square over qv. So totally current will be just n0 aq over root 2m d square over qv. See, here we have expression, but it contains area and distance, but we need to use other parameters. Now we can see that we have capacitance here, and capacitance we can count from geometry and epsilon zero. We have capacitance equal epsilon 0 A over D, and we can rewrite this expression in form of n0 A over D, and here we have Q over root 2m over qv, and this is capacitance divided by epsilon 0, so that will be C over epsilon 0, and finally we have this expression C over epsilon 0 and 0q and root from qv over 2m. So that's the expression for current. We can rewrite it here, C over epsilon 0 and 0q root qv over 2m. Next question is D. Derive an expression for the effective resistance of the device in terms of epsilon 0, in these terms of epsilon 0, m, q, and 0, c, v. So, resistance we know that's equal voltage divided by current. We already counted what is current, so it means that resistance equal epsilon 0 over C and 0 Q root from 2m Q over V. That's effective resistance. See, this element is not linear. Resistance decreasing when voltage is increasing. So we can rewrite it here, epsilon 0 over C and 0q root from 2m over qv. And the last question is calculate the rate at which the kinetic energy of the balls is converted into thermal energy in terms of same variables, same parameters. Sorry. We know that this rate or the power that's equal voltage multiplied by current. And so we already counted what is voltage, what is current, and finally using this formula we have answer root from epsilon 0 square and 0 square C square Q cube V cube over 2m. So this is the answer. We can rewrite it here, epsilon 0 square and 0 square c square q cube v cube divided by 2m, all under the root. That's it.